Energy powers our lives. Everywhere you look, it's at work. The lights in our homes, the cars on the roads, the computers we use for work and play, all of these depend on energy. It's the invisible force that keeps our modern world running smoothly, from the smallest gadgets to the largest cities. But did you know that some of the most incredible power comes from things far too tiny to see with the naked eye? That's right, atoms. These minuscule building blocks are the foundation of everything around us, and they hold secrets to energy beyond imagination. This is the secret behind nuclear energy, a force that comes from the very heart of matter itself. When we unlock the energy inside atoms, we tap into a source so powerful, it can light up entire cities, or even change the course of history. Atoms are everywhere, inside you, inside me, floating in the air we breathe, and shining in the stars above. Every object, every living thing is made up of countless atoms, each one a tiny universe of energy and possibility. Some atoms, like those found in certain elements, hold an astonishing amount of energy just waiting to be released. When we learn how to unlock this energy, we open the door to incredible possibilities for powering our world. Today we'll explore how uranium, a special naturally occurring element, can be transformed into a powerful source of energy. This single element has the potential to power entire cities, providing electricity for millions of people. Imagine harnessing the same energy that holds the universe together, right here on Earth. It's like capturing the power of the stars and using it to light up our homes and fuel our future. We'll take a closer look at nuclear reactors, amazing machines designed to safely unlock atomic energy. How do they work? Are they safe? What are the benefits and challenges of using nuclear power in our everyday lives? These are important questions we'll explore together. Let's unlock the secrets of the atom and discover how science and innovation are shaping the world we live in, making it safer, cleaner, and more exciting than ever before. Are you ready? Let's embark on this journey and explore the incredible power of the atom together. So, what exactly is uranium? You might have heard the name before, but let's take a closer look at this fascinating element and why it's so important to our world. Uranium is an element just like gold, oxygen, or iron. But what sets uranium apart is its incredible weight. It's one of the heaviest, naturally occurring elements on Earth. If you held a chunk of uranium in your hand, you'd notice it feels much heavier than most other rocks of the same size. Despite its reputation, uranium isn't actually that rare. You can find it in rocks and soil all over the world, from remote deserts to mountain ranges. In fact, there's a little bit of uranium in almost every patch of ground you walk on. Uranium has been part of our planet since the very beginning. It formed in ancient stars long before Earth existed, and when our planet came together, uranium was already here, making it older than the dinosaurs, older than the mountains, and even older than the continents themselves. But uranium isn't just heavy and ancient, it's also a bit unstable. This instability is what makes uranium so unique and in some ways so powerful. Some types of uranium atoms, called isotopes, naturally break down over time in a process called radioactive decay. As they decay, they release energy in the form of radiation. This property is known as radioactivity, and it's what gives uranium its reputation for being both useful and dangerous. The most common isotope is uranium-238, which makes up about 99% of all natural uranium. But when it comes to nuclear power, scientists are especially interested in a much rarer isotope, uranium-235. Uranium-235 is incredibly rare, less than 1% of all uranium found in nature. Yet this tiny fraction is the key to unlocking nuclear energy because it has a very special property. Unlike most atoms, uranium-235 can split apart when it's hit by a tiny particle called a neutron. This splitting process is called fission, and it's at the heart of how nuclear power works. When a uranium-235 atom splits, it releases a huge burst of energy, far more than you'd get from burning the same amount of coal or oil. This energy can be harnessed to generate electricity for cities and homes. This is the secret behind nuclear power plants. They use the energy from splitting uranium-235 atoms to produce massive amounts of electricity, all without burning fossil fuels. So, uranium-235's special trick, fission, is what makes nuclear reactors possible, and why uranium is so valuable to our modern world. But how does this atomic superpower actually work? What happens inside a nuclear reactor, and how do we control such a powerful force? The story of nuclear energy starts right here, with uranium and its remarkable ability to unleash the power hidden inside atoms. Let's dive deeper and see how it all comes together. Uranium-235's superpower is nuclear fission, splitting apart. Imagine a neutron hitting a uranium-235 atom. The atom absorbs the neutron, becomes unstable, and splits into two smaller atoms. This split releases a huge burst of energy, millions of times more than burning coal or wood. But there's more. Each split releases more neutrons, which can hit other uranium-235 atoms. This creates a chain reaction, like dominoes falling, with each split causing more splits and more energy. Scientists control this chain reaction to generate heat in a nuclear reactor. It's this controlled cascade of splitting atoms that powers entire cities. Fission is the heart of nuclear energy. With just a tiny bit of uranium, we unlock massive power. That's the science behind the atom's energy. Let's see how we use it in a reactor. How do we use fission's power safely? Inside a nuclear reactor. The heart of the reactor is the core, packed with fuel rods filled with uranium pellets. These pellets are like tiny batteries, each loaded with potential energy. When uranium-235 atoms split inside the fuel rods, they release intense heat. The reactor core gets incredibly hot, thousands of degrees. The arrangement of fuel rods is carefully designed to keep the chain reaction steady and safe. The core is built to contain heat and radiation and to keep the reaction under control. Engineers monitor and adjust the core to harness atomic power precisely. It's a marvel of engineering, turning atomic fire into usable energy. The core is where the magic happens. Next, let's see how we control this powerful reaction. Safety and precision are everything. Controlling a nuclear chain reaction is absolutely crucial for the safe operation of a nuclear power plant. Without careful management, the reaction could quickly spiral out of control, leading to dangerous situations and potentially catastrophic consequences. If left unchecked, a nuclear chain reaction can release energy at an extremely rapid rate, far too quickly for the system to handle safely. This is why constant monitoring and precise control are essential. To maintain this delicate balance, reactors are equipped with two key components: moderators and control rods. These work together to keep the reaction steady and under control. Moderators, which are often made of ordinary water or sometimes graphite, play a vital role. Their job is to slow down the fast-moving neutrons produced during fission. When neutrons are slowed, uranium-235 atoms can capture them more easily, making the chain reaction more efficient. By reducing the speed of neutrons, moderators help sustain a steady, controlled chain reaction. This ensures the reactor produces a consistent amount of energy, rather than fluctuating wildly. Control rods, on the other hand, are made from materials like boron or cadmium, which are excellent at absorbing neutrons. Their main purpose is to capture excess neutrons that could otherwise cause the reaction to accelerate uncontrollably. Engineers can carefully move these control rods in or out of the reactor core. Inserting the rods deeper into the core absorbs more neutrons, slowing the reaction. Pulling them out allows the reaction to speed up. Lower the rods and the reaction slows down. Raise them and it speeds up. This precise movement allows operators to fine-tune the reactor's power output to match demand. In emergency situations, control rods can be dropped fully into the core almost instantly, stopping the chain reaction and shutting down the reactor safely within seconds. Thanks to these systems, nuclear reactors remain safe, stable, and reliable sources of energy, even under changing conditions. It's all about maintaining the perfect balance, producing enough energy to power our cities, but never so much that it becomes unsafe. Moderators and control rods truly are the unsung heroes of nuclear safety, working quietly behind the scenes to keep everything running smoothly. With their help, we can harness the immense power of the atom, while keeping people and the environment safe. Now let's explore how the heat generated in the reactor core is transformed into the electricity that powers our homes and industries. The reactor core's heat is used to boil water. Just like a giant kettle, the boiling water turns into high-pressure steam. This steam rushes through pipes to spin a huge turbine like a windmill. The spinning turbine is connected to a generator. Inside the generator, spinning magnets and coils create electricity. This electricity travels through power lines to homes, schools, and businesses. So, atomic heat becomes the light in your room. It's a classic trick. Heat to motion, motion to electricity. That's how nuclear power lights up our world. Safety is the top priority in nuclear power. Reactors have many layers of protection like Russian nesting dolls. Control rods can quickly shut down the reaction in an emergency. a process called a scram. The reactor vessel is made of thick steel, surrounded by reinforced concrete to contain radiation. Cooling systems constantly remove heat, even after shutdown, to prevent overheating. Multiple backup systems ensure safety, even if one fails. Past accidents like Chernobyl and Fukushima taught valuable lessons. Each incident leads to new safety improvements and stricter regulations. Engineers are always learning and updating designs to make reactors safer. Vigilance and innovation are key to nuclear safety. The goal: protect people and the environment always. Nuclear power story is one of constant improvement. Safety never takes a break. Nuclear power is a clean energy source. It doesn't release greenhouse gases during operation. A tiny uranium pellet can produce as much electricity as a ton of coal. This means less mining, less pollution, and a smaller footprint. But nuclear power has challenges, especially dealing with radioactive waste. Used fuel remains dangerous for thousands of years and must be stored safely. Solutions include cooling pools, dry cask storage, and deep underground repositories. Scientists are also researching reactors that can use waste as fuel. Managing nuclear waste is a big challenge, but innovation continues. Nuclear power offers huge benefits and big responsibilities. The future depends on smart solutions. Nuclear science does more than power cities. It saves lives and explores space. In medicine, radioactive isotopes help diagnose and treat diseases like cancer. Spacecraft use nuclear power to travel far from the sun, exploring distant planets. Nuclear-powered ships and submarines can travel for years without refueling. Industry uses nuclear tech for safety checks and sterilizing equipment. Nuclear energy offers clean power but demands careful management. Science keeps pushing boundaries, finding new uses and safer solutions. Understanding nuclear power helps us make better choices for our world. Stay curious, keep learning, and explore the wonders of science. The future is bright when we harness the atom wisely.